Yeah, sure. Uh, Bhanu Teja, can you please share your PPT so that before we start, we'll just check.
Okay, sure. I'm sharing my PPT. Mhm. Yeah, is the
Bhanu,
screen visible?
yeah, your screen is visible. Just small request. You have joined from two devices, so I request to keep mute one device so that there will not be any echo.
Sure, sure,
So
sure. I have muted my other device.
yeah, done. We can see your screen. Just go to your presentation. Yeah, we can see. Is it on cloud? Yeah. Now we can see completely. Yes, Sita ma'am, go ahead.
Yeah. Mhm. Good evening, all. Welcome back again for the session three of the day. For session three, we have among us Mr. G. Bhanu Teja. He is currently working as a senior software engineer at Map India in New Delhi, where his work is mainly focused on developing 3D immersive products, simulations, AR VR projects using Unity and Unreal engines. Previously, he worked at Geo Tesseract in Navi Mumbai, contributing to the development of Geo MR SDK and app for India's first mixed reality consumer headset, that is Geo Glasses. He has vast experience of immersive technology domain. I request Mr. Bhanu Teja to please start with the session. Over to you. Please unmute yourself, Bhanu Teja. I think your mic is muted now. You are not audible.
Hello?
Yeah, yeah. Now it's okay.
Okay. I'm starting my presentation.
Yeah, please go ahead.
Hello, everyone. Good evening. My name is Bhanu Teja. So let's get started with today's session on Beyond Boundaries, Immersive Realities in Space Technology. Just a second, I'm reducing the volume on my mobile device. So I would like to start the session by introducing a project that we have recently developed. It showcases the ISRO's PSLV C60 SpaceX mission. So in this mission, what is happening is that India will be demonstrating our own docking technology in the low Earth orbit, which is developed by ISRO. So once we are successful with this mission, India will become a fourth country which is having its own docking technology for docking any two satellites or any two spacecrafts in Earth's low Earth orbit. So I would like to start with a video showing the project that we have developed. So, so this is the Unity engine in which we have developed the simulation. So once we start the start launch button, the docking sequence will start, and you can see that the rocket is in the docking sequence. So now the rocket has lifted off. Uh, you can see that India's second launch pad at Sriharikota is also visible, and you can see Earth's atmosphere, and the rocket is also heating up in the Earth's atmosphere. Now the first stage of the space rocket will be separated. Yes, first stage is separated. Now we are in Earth's low Earth orbit because the atmosphere is gone, so the heat shields have been separated, and now the second stage will be separated. Yes, you can see. So after that, the third stage has been separated. We are in the last stage in which the PSLV stage 4 will be deploying the satellites. You can see the satellites have been deployed, and now we are in the Earth's low Earth orbit, and you can see the day and night which is happening on Earth. So in reality, also it looks like this only when seen from such a large distance. You can see the satellite is revolving the orbit. The second satellite is also visible. So once you press the start docking button, so the docking sequence will start, and the satellite, the chaser spacecraft will come towards the target, and they will dock with each other. So the docking has been succeeded, and you can see once the docking is completed, though both the satellites will revolve in their orbit together. Previously, like they were revolving separately, no, by maintaining a distance of around 2.5 kilometers between each other. Now they are like revolving the orbit together. So this was a small video showing the simulation of the current mission. In future, like we will be like also developing one functionality so that one of the payloads onboard this mission is robotic space debris capture one. So what happens with that payload is that it's a robotic arm which is capable of catching the space debris in the low Earth orbit, because once the satellites are launched and their mission lifespan is over, so the satellites are uh, like become junk in the Earth's low Earth orbit. So that's why like using this robotic arm also, we will be demonstrating a mission in which we can like capture the debris which have been accumulating in the low Earth orbit. So let's get started with the immersive technologies in space exploration. So let's start with virtual reality. How many of you have heard about virtual reality? Am I audible?
Yes, yes.
Okay, okay. So virtual reality is a technology using which like we can experience computer generated information in a virtual world. Like we are like seeing everything, so it's reality. So similar to that, like in virtual world, what happens is that the user is completely immersed into a virtual environment. Yes, somebody has raised their hand.
Yeah, I'm from Oil and Natural Gas Corporation.
Yes,
Hello.
hello, sir.
We
Hello, yes, sir. You
were
are audible.
uh, we were using this virtual reality for seismic data exploration and see the maps and all through virtual reality mode, so that we could identify the where the exactly the locations are. Because underground exploration, the maps are very complicated, so we could see in the virtual reality mode since quite long about that. Since
Mhm.
beginning about 20 years back, we are doing.
Yes, yes. VR has so many use cases because the situations in which we can't exactly see what is happening in reality, we would have to like simulate now. So it's having so many use cases to like simulate such scenarios beforehand, so as to improve the efficiency and performance also. So like VR is quite useful in astronaut training also. Like before, like the astronaut goes into space, they can use virtual reality like VR headsets to like immerse themselves into a space environment beforehand, and they can experience zero gravity environment, which they will be experiencing in the low Earth orbit or in the higher orbits also. So like it will be useful for mission simulations also. Like we can like develop the entire simulation of the mission so that the astronauts can experience and they can like get to know what the situation will be like in the real environment beforehand. It will be quite useful for celestial bodies exploration also. Like we can simulate the atmosphere of Mars and various other planets, and we can experience how it's like to be present on Mars surface. Like NASA and Russia and China has been like sending spacecrafts and rovers on Mars since a long time. India also had a mission called Mangalyaan, in which we have like sent our first spacecraft outside Earth's atmosphere, Earth's low Earth environment. Uh, Back it was a quite successful mission, but we haven't yet sent any landers. Maybe like in future we will be sending some lander to Mars also, like we have sent to Moon, Chandrayaan 3. Like there are many applications of VR in space. Like you can also see that in Earth's low Earth environment, ISS is present, International Space Station is present, which has been launched into. Just I'm like hearing my own echo. Hmm. So ISS has been launched into low Earth orbit after so many like uh, launches. I would like to show one video in which like Meta has developed a mission ISS app in which like we can explore the entire International Space Station virtually. I will later show this video, show the real world experience also by like wearing the MetaQuest 2 also. So this video I have recorded while like using this app on MetaQuest 2. So this is how ISS looks like from the low Earth orbit. Is the audio also is the audio audible of the video? I
No,
think
please.
No.
it's not audible. Let me share once more. So this is how the International Space Station looks from inside. You can see that we are like in a zero gravity environment. So if I throw some object, like it's interacting, how it would interact in the zero gravity environment, it will just fly away because gravity is not there. So ISS has different sections. So in this app, we can go to whatever section we want to visit. Like currently, we are like in I think the destination Destiny lab. So you can see that how Earth will look like from this window. I think I will demonstrate the app itself. It will be much better while wearing the MetaQuest 2. So what you are like seeing here, no? So this is MetaQuest 2. It's a virtual reality headset. I will show how the latest VR mixed reality headset Quest 3 also looks like. Just a I will share my Oculus screen. I guess my screen is visible.
Yes, visible.
Let me launch the app and show it to you how it looks like in VR. So these are the two controllers using which we can interact in the virtual environment. Just as I'm adjusting my boundary. So you can see this is the International Space Station. I will choose the explore mode so that I can show it quickly. So you can see that I am inside the space station. So because I'm in a zero gravity environment, if I you can see my hands. You can see my hands. I guess you can see my hands. So if because it's a zero gravity environment. So if you want to walk in the environment, you have to grab some objects, grab these stand. Then only you will be able to move around. Like if I want to hold this toolbar, it will just fly away. I'm trying to catch it. So I'm holding this thing. So if I just throw it, it will fly away because there is no gravity. So you can see that just a second. I am holding this screwdriver. So if I throw this, so you can see that it just flies away. I'm using thrusters to stabilize myself. So I'm let me see where I'm currently. So currently I'm at node 2, which is in between Columbus and Kibo nodes. So if I want to go outside the spacecraft, I think I have to go to the spacewalk section. So you can see that I'm I'm grabbing the objects because so now I will go outside and let me show you how it looks like. I guess from here I will go outside. So there is a window here from which I can see how Earth looks. So I'm seeing from this window. You can see Earth is visible. I'm going outside the space station. So you can see that I'm outside now. So let me rotate myself. You can see sun is visible. This is the outer space. I'm like thrusting myself to the top. So let me grab something. So you can see sun. So this is the Canada arm. This is developed by Canada Space Agency. This robotic arm is like capable of like moving uh, objects in space which can't be moved by humans. So this is the robotic arm. Let me go near to it. So this is how like astronauts in space also have to like walk around the International Space Station to do any repairs if something happens. Because a space launch can't happen whenever there is any requirement. So you can see the solar panels are also like visible. So we are slowly moving the Earth's orbit. So let me go to some other location. Uh, let's go to Russia's capsule. Like International Space Station is a cooperation between like many like few countries like Japan, Canada, Europe, uh, and two more countries. Russia is also part of it. So this is the Russia's capsule, where Russia uses Soyuz satellites to launch into the space. So whenever a Soyuz rocket wants to dock with the International Space Station, the crew module comes here and it docks to this window. Like if I want to go a little bit higher, I can show you. So this is the part where like the crew module docks to the International Space Station. You can see the port. So similar to this only like ISRO is also like demonstrating this paired expression in which we will be like developing demonstrating that technology beyond our own space docking system. So like if I go downwards, so this is the life support system, and this is the antenna used for communication with the ground stations. I'm trying to move a little bit higher so that like the entire space station is visible. You can see. Let me go some more further. So this is how International Space Station looks like from low Earth orbit. It's at around like 400 plus kilometers, 475 kilometers. So you can see the ground control is telling that I am venturing farther away from the ISS. So at this distance, it will not be able to capture the astronaut if like they go farther away. So this is the Japan's module. Let me grab something. I will resume with the presentation for now. We'll show one more app once again. So as we were like discussing what are the applications of virtual reality in space, it's like useful for simulations also. Like we previously discussed about how VR can be useful for simulating virtual worlds. So we can create virtual worlds using the data which is captured by the rovers, and astronauts can like immerse themselves in that environment. Not only astronauts, the normal consumers and everybody else can also use applications developed by space agencies or other institutions to like immerse themselves in this virtual environment. like uh, so if I show you this image I had like captured when I was like using one simulation app in which the data captured by the Curiosity rover can be explored virtually. So this thing also this image shows like how the atmosphere of Mars looks like from its surface. This is one of You can see one headset which is visible in the slide. This was a prototype VR headset developed by NASA back in 1985 for simulating virtual worlds, so that for their human human spaceflight program, they can like immerse themselves in the virtual environment, and they can like explore. These are some facts of this headset. Like Now let's discuss the timeline of virtual reality. Virtual reality term was coined back in 1962 when Sonorama was like developed. So in the timeline only, like back in 1985, NASA has developed a prototype VR headset. After that, like Nintendo also developed one virtual reality consumer headset in 1995. It was not a successful headset because it was costing a lot at the time, because like the technology was limited, so the manufacturing cost was too high, so not everyone will be able to afford back then. So it was 1995, and now we are like currently in 2025, and Meta is talking about metaverse and all those things. So gradually so many companies started launching their own headsets. Previously, in the initial phase, Google also demonstrated their technology using Google Cardboard, how a low cost VR headset can be developed in less than $20, so that everyone can experience how virtual reality looks like back in 2014. Later on in 2016, most of the consumer VR headsets came in 2016 only, when so many companies started launching their own headsets like Sony, HTC, Oculus, Google. Oculus was a company which you must be knowing about. So it is the company which has developed MetaQuest headsets. Oculus later got acquired by Facebook. Later, as you know, Facebook has changed their name to Meta. So the entire Oculus platform is now owned by Meta. So they are only developing the entire virtual reality ecosystem using the Meta Presence platform. So in 2017 to 2020, many more companies also started coming into this domain. So these are some of the headsets which Meta has launched till now. Meta Quest 2 was one of their like first launches back in 2020, so that increase the VR consumption for the mainstream users. After that, like Meta has launched the Meta Quest Pro. So Quest 2 was a virtual reality device. It was not supporting mixed reality. Mixed reality we will discuss later on in this presentation. What is mixed reality and what is augmented reality? Virtual reality, you must have like understood by now that virtual reality is a technology using which we can like immerse ourselves in a virtual environment. Uh, so later on, Meta has launched Quest 3, which was launched 2 years ago. It's a mixed reality headset, which is a low cost version of Quest Pro only. And last year Meta has launched Meta Quest 3s, so it's even much more cheaper than Meta Quest 3, so that more users can experience what mixed reality looks like, because mixed reality is much better as compared to virtual reality. That also we'll be discussing in the later slides. So now let's discuss about how VR is useful in Indian space context. 2 years ago, India has launched the first moon mission back in 2009 with Chandrayaan 1, and Chandrayaan 2 was launched in 2019. It was not complete success, but we have like learned a lot from that mission also. Chandrayaan 2 orbiter still continues orbiting moon's orbit, providing valuable data to ISRO for the future missions. Like the same data which was captured by Chandrayaan 2 orbiter was used in the Chandrayaan 3 mission also for successfully landing India's first lander on moon's south pole. India became first country to land on the moon's south pole, and the fourth country after USA, Russia, and China to successfully land on moon's surface. So in India space contest, Israel is like developing VR simulators so that astronauts can get used to what the zero gravity environment will be like. So IIT Madras is mainly like collaborating with ISRO for developing those training modules for Gaganyaan mission also. Like you can, I will share the PPT also so that everyone can go through these slides. So this was a MOU signed by IIT Madras to develop Gaganyaan training simulator. So for Chandrayaan 3 and future lunar missions also, VR can be used to accurately map the surface data and pre-plan what the mission will be like, so that like the scientists and all the tech people can like plan the mission much much better and at a lower cost, because simulating everything in a real environment, it costs a lot. So if we can like simulate everything virtually, the cost of like doing that will be near zero. So uh, I will I would like to show one more app which we have developed I think 1.5 year ago for Chandrayaan 3 mission. So this time I will show it in MetaQuest 3, which is the latest headset in which like mixed reality is also like possible. So previously you have seen the headset MetaQuest 2. So this is a virtual reality headset. So MetaQuest 3 is a mixed reality headset. So you can see that there are three cameras. Two cameras are RGB cameras, red, green, blue, which allows us to see the real world in color. And there is a depth sensor at the center. So the depth sensor is useful in like simulating the real environment virtually, because the depth sensor can sense the entire surface and it can like map entire and the complete room and whatever like wherever we want the simulation to take place, it can map the entire thing so that we can use the real world objects inside the virtual environment. So let me stop the slides and I will. So you can see my real environment also in Questry. So this is the real world in which and you can see the virtual hands. Is it visible?
Yes, yes, it is
Yes.
visible. Yes.
Okay, okay. So Questry useful in simulating the virtual world with the real world, which is known as mixed reality, in which we can experience both virtual reality and augmented reality in our real world. So you can see this is Chandrayaan 1. So this was dropped from Earth's orbit, uh, lunar impact probe, I guess. And this was Chandrayaan 2 lander, which was which would try to land on moon surface, but unfortunately it crashed on the moon surface at the last stage. And let's start with the simulation showing the entire mission of Chandrayaan 3. So you can see that I am currently present in Sriharikota, India's second launch pad. So you can see the GSLV Mark 3, which is also known as LBM-3 M4 rocket. So let me click on this info button, which tells about this mission briefly. So let me start the launch sequence. So once you press the launch button, it will start the launch sequence. So the pad is getting separated. Rocket is about to lift off. Now the camera will be switching to the Earth's atmosphere, so that you can see the all other stages of the rocket. So now we are in Earth's atmosphere. You can see the rocket getting moving towards the space. The two S200 strap-on boosters have been separated. Now the first stage will separate itself. The payload fairing has separated because heat shield is no longer needed because we are outside Earth's atmosphere. So you can see the last stage is like uh, revolving Earth's orbit. Slowly it will like increase the orbits. TLI means translunar injection. So the satellite will be separated from Earth's sphere of influence. So the last stage has separated. It is slowly moving towards moon. You can see the timer also, like how much time it has been after launch. So the lander is like revolving Earth's sorry moon's orbit. It slowly descend onto the moon's surface using the Vikas engine. So you can see that it will slowly land on the surface. Now the rover will come out of the lander. So this was the mission showing the simulation of Chandrayaan 3. And let me close this thing. So in mixed reality, the benefit is that you can see the both virtual world as well as the real world. So I'm like interacting with the virtual elements here, and I can see my real world environment also. So this is the quest 2, and I'm in quest 3. You can see this like if I want to like open something else. Previously, I have like shown this mission ISS app, and this was the app that I had developed. Okay. I will share the slides once again. Let's continue with the presentation. So in virtual reality, there is a term called degree of freedom. So degree of freedom is the number of ways in which like a virtual object can move itself in the three axes x, y, z, and like there are two different terms called 3 degree of freedom and 6 degrees of freedom. 3 degrees of freedom means like we can only like rotate around x, y, and z axis, and in 6 degrees of freedom we can like rotate the virtual object in x, y, and z axis, as well as we can like translate in those axes. Like the virtual object can move in the x direction, it can move in the minus x, y, minus y, z and minus z. Y means upward and downward. So like if I show this, you can see in this image the difference between 3 degrees of freedom and 6 degrees of freedom. So when the user is wearing the headset in 3 DOF, like he or she can like rotate their head x, y, and z direction. Like they can rotate in y direction only, but the virtual object, it will look like as if rotated in both the like all the three axes x, y, z. And in 6 degrees of freedom, the user has the freedom to like move rotate in x, y, z directions, as well as the user can like translate in x, y, and z direction. Like you can rotate yourself and you can move in those three axes. So 3 DOF means 3 DOF experiences are mainly like for mobile based VR, like Google Cardboard and all the low cost consumer headsets, which was a old technology which was launched a decade ago. And 6 DOF headsets are like the latest headsets in which like we can like immerse ourselves in a virtual environment, and we can do whatever we can do in the real world in the virtual world also. Like all the simulations that are developed, they are mainly 6 DOF, because like if we want to like experience ourselves how we can feel in that particular virtual world, we need 6 DOF. So this is the same thing that I have like explained. 3 DOF headsets are like Google Cardboard, Oculus Go, Samsung Gear VR, Google Daydream, and these are the 3 DOF headsets which were launched a while back. Google Cardboard was launched back in 2014. Google Daydream was launched back in 2016. Oculus Go was a success. It was launched back in 2018. Samsung also tried to like launch their own headsets in 2015, but after that like they have stopped in the domain. 6 degrees of freedom we had discussed, like we can rotate the virtual object, and the virtual object can move in those directions also. So these are 6 of headsets. Oculus Rift was launched back in 2016. It's a PC VR headset. There are like two types of headsets in virtual reality also: standalone and PC VR. Standalone means like the headset has an onboard processor, GPU, RAM, storage, uh, flash memory also, so that everything can be done internally on the headset only. But in case of PC VR, you can see in Oculus Rift there is a headset. It's uh, it is used as a rendering device only, but there are to track the real world and the virtual world. It uses the trackers. You can see the trackers are here, so it helps the device to track and map the virtual environment in the real world. Mm, the advantage of standalone headset is that we don't need expensive PCs to like power the headset, because in PC VR, like what happens is that it does not use its own processing power to render the virtual object. It uses the PC's GPU and CPU to do all the computation, and then it will just render whatever has been done by the CPU and GPU onto these virtual screens. Whereas in standalone headset, it uses the embedded CPU GPU to do all the computation on the device itself. So it's much better to increase the adoption of virtual reality for the consumers. So now let's move to augmented reality. In virtual reality, like we are immersing ourselves in the virtual environment. But in augmented reality, what happens is that the computer generated information is completely overlaid in the real world, as you have like seen in the MetaQuest 3 also. The virtual the operating system has been overlaid in the real world camera feed, and we can use all the apps, virtual apps in the real world, as well as the mixed reality apps also. So you can see that in augmented reality, mainly mobile based AR devices are used. If I have to like show you one AR application that I had developed back in 2021, AR solar system, let me show you that as well. I will stop my video for few seconds till the time I will be showing the tab. I guess my screen is visible. Are you able to see my phone screen?
Yes.
Okay. Mhm. This is one app that I have developed back in 2021. So you can see the how augmented reality works. But you can see this solar system. All these virtual elements are overlaid on top of the camera feed, so that we can like interact with it. You can see this asteroid belt. If I move a little bit closer towards the earth, I guess like You can see that I can interact with the virtual object also in the real world. I'm rotating the Earth, and if I want to see the information, I have to press on this info button. It overlays the information of this planet. If you want to download this application, it's available on Play Store also. Let me share its link. I will share it later, I guess. So AR also has a lot of use cases in space exploration and space domain also. Like with the help of AR, like the astronauts can get help from the ground stations. The technical experts can see the camera feed of the astronaut, what they are like working on, and if they are if they get into some issue and they are not able to resolve the issues by themselves because they have limited resources on board ISS or like any other spacecraft, so they can get real-time help from the ground station by the ground station, the technical people from the ground station, they can like see the overlaid information of the real world, and they can like guide the astronaut in resolving the issues. AR has use cases for AR assistance procedures also. The same thing that I have talked about, no? Remote assistance app. Also, if I open this URL, we can see how NASA is using AR and VR in space technologies. Uh, I will share that screen. So, this was what I was talking about. AR remote assistance app. The device that the astronaut is wearing is Microsoft HoloLens 2. It's a augmented real. It's an AR device using which the what the astronaut is seeing, the camera feed is like getting transmitted to the ground station so that like they can see and help with the task. Previously I was wearing a headset similar to that. Like these astronauts are also wearing these headsets to work on some simulated tasks. and astronauts can because in the space, like they won't be able to visit any place which they want to visit on Earth, so they can visit virtually in space using these VR headsets. This is what I was talking about, the AR maintenance remote assistance app. So if we discuss about the timeline of AR headsets, AR was first conceptualized for a long time back, but it was launched in a form of headset for consumer by Google back in 2011 as Google Glass. And after that, Meta launched smart glasses. It's not the same company that we know about currently. Meta was a company back in 2014 which was manufacturing AR headsets, but they were not successful. So the company uh, got into insolvency. So after that, like Wufora came up with an SDK for mobile-based VR. So using that SDK, we can like develop AR apps on mobile devices. Uh, Wuforia's like approach was quite popular back in the 2015 and after that also, because mobile device is with everyone. So it may be quite it may become wide mainstream as compared to virtual reality, because back then virtual reality headsets were costing a lot as compared to mobile devices. After that, like Microsoft also came into the picture, and they launched HoloLens back in 2016. It was the first generation device, HoloLens device, for augmented reality applications. And then Magic Leap also like launched their headset back in 2018. After that, similar to Vuforia, Apple also launched their own SDK called ARKit for mobile-based AR on iOS platform back in 2017. And after that, like Google also launched for Android an SDK called AR Core back in 2017. And the last AR headset that was launched was Microsoft HoloLens back in 2019. It's the same headset that was used in the International Space Station also for remote assistance. This task. Few of the AR headsets that I work with are GeoGlass, RealVR, and Magic Leap. I was previously talking about GeoGlass. Like previously, I had worked at GeoGlass also, developing an SDK for India's first consumer mixed reality AR glasses. So this is how it looked like, GeoGlass, and this is a real VR headset, and this was Magic Leap. So now let's talk about mixed reality. Mixed reality is a technology which blends virtual and real world elements, uh, creating a interface between the real world as well as the virtual world, so that the user can see both the virtual as well as real world, and user can interact with the virtual world elements in the real world itself without like having to immerse themselves into a completely different virtual environment. MR can be useful in collaborative design and engineering, like what we are like currently doing on Google Meet, like Microsoft Teams or Google Meet. Like we are like joining the meetings in 2D. We are like seeing all the things on a 2D screen. But if we can join the same thing on a 3D screen, 3D screen means what I have previously shown using the Metaverse headset. Multiple users can join, and we will be having a lot of we will not be having a limitation of space, because in 3D the space is infinite. We can do whatever we want in the virtual environment, uh, and we can plan our task, and we can do it in a much better way as compared to what we can do on a 2D screen. So mixed reality can be useful for mission planning and rehearsal also, similar to what VR headsets can do. It can be useful for mixed reality applications also, robotics and teleoperations. MR can be useful for uh, training robots virtually, like simulating and developing a complete robot takes a lot of money and effort. But if we do the same thing in a virtual environment, we can train the robot completely using the simulated environment, using real-time game engines like Unreal Engine, Unity Engine. uh, so it will be a quite cost effective way to train robots. For training and education also, mixed reality headsets are quite useful, similar to the solar system application that I have like shown you previously, AR solar system. So many simulations can be developed for all the different topics, which will be useful for. So let's talk about the modern MR headset. So this is Metaverse 3 that I have previously shown also. So it's the latest mixed reality headset, using which we can do whatever we want, like whatever application we want to do virtually, we can do it in the real world with the help of mixed reality. MetaQuest Pro was launched back in 2021. Now it's deprecated because the cost of manufacturing a MetaQuest Pro headset is a lot more as compared to MetaQuest 3. And MetaQuest 3S was launched back in 2024. And Apple also came into the picture by launching Apple Vision Pro back in 2023. Uh, Currently they have like stopped the production of Apple Vision Pro because the cost is quite high, like around $3,500. So I don't think any consumer will be spending a lot that much amount of money to buy a gadget using which like they want to do mixed reality. So I guess like for now, like people will be sticking to Meta headsets only until and unless some other player comes into the picture and launches a even more cost effective headset which has all those features which are available in the Meta headsets. So there are some mixed reality headsets by Indian companies also. It's not that India is not into this AR VR headset manufacturing. So previously, like GeoGlass was launched back in India Mobile Congress in 2022. Uh, Modi ji has like launched 5G while wearing the GeoGlass. So Akash Ambani was like presenting him like some application developed back then. One more company is called Asna Lens. So they are also like developing mixed reality headsets. They launched their headset back in 2023 at CES. So this is one more AR glasses called Nemo One glasses by Nemo Planet. It was also unveiled back in 2023. Uh, it's one virtual reality headset developed by one startup called Question What's Real. uh, Before starting with development and all those things, like how AR VR applications are developed, if somebody has any question they can ask and we can like take up all those questions and later on we can continue with the development.
Please continue. We'll take questions in last.
Okay. Just a second, I'm sharing once again. Uh, I guess my screen is visible.
Yes, it is visible.
So previously I have like shown one application that I have developed now. So let me tell you about Unity Engine. So Unity Engine is one of the game engines used for developing AR VR applications. It's a real-time game engine, but it can be useful in developing games as well as apps also. Many real estate companies and so many industries use this engine to develop simulations and VR MR applications. So if I want to download Unity, first of all, I have to go to unity.com. Then you can, or else I can just type it. First, you have to go to this link unity.com/download. I will put it into the chat box. So Unity Hub is an application for like managing all the Unity developed projects centrally, and it manages all the engine versions also. Once you install the Unity Hub from this by clicking this download button, it will try to download the setup of that application. Because I have already installed the Unity Hub, I will ignore this step and I will proceed with the Unity Hub application. Once you install it, you can find the Unity Hub. So this is how Unity Hub looks like. So all the projects that you will be developing, they will be appearing here. Uh, and if after opening the Unity Hub, you have to install a version of Unity for developing the application. So all the installed versions you can like see from this install menu. Uh, like I have installed all these Unity versions. So if you want to install the Unity, you have to go to installs. Then you have to click on install editor. Like you can see all the uh, various engine versions which are available from this tab. So all these are official releases by the Unity. You can install Unity 6, which is the latest version of Unity. But if you want to install some other version of Unity, you can go ahead and install from here also. LTS means long-term support. When you are like starting with the project, you have it would be much better to install a LTS version, because LTS version will be supported for a much longer period as compared to normal releases. So if there is some bug in the Unity engine, they will be like resolving those bugs, and like they will be sending the update of the version. But for all other releases which are not LTS version, they won't be like updating it quite frequently. After you install the Unity, the engine version will appear here, and for creating a new project, you have to once again go to the project tab, and you have to like click on this new project tab, which will like show you this menu. So let's go ahead and start with a new project. These are all the different templates which are available before creating the project: 2D, 3D, universal 2D, universal 3D. 2D means like this template is used for creating 2D applications, and 3D means like you can build 3D applications using this template. About URP and all those things, I will explain later on. So from this top menu, you can like choose which version you want to, which version of Unity you want to use for development. Like I have all these versions of Unity installed, so I'm choosing 2022.3.23 F1, which is the LTS release. You can choose any option that you want to choose. Like if you have installed Unity 6, so Unity 6 will be appearing here. So after that, like you have to like after choosing the Unity version, you have to like give the location where you want to store this project. So let me show you. I'm like developing like I'm storing it here. I will you have to give a name to your project, and after that like you have to click on this Unity. You have to choose the organization in which like you want the project to be part of. For creating the organization, you can just go to unity.com, and if you click on this Unity dashboard, so it will be showing a dashboard where which looks like cloud.unity.com. So from here you can like choose and manage all the different organizations. If you click on this manage organization button, you can see like what all organizations are available for developing the project. If you want to create a new organization, you can like go to like they have like changed the theme. Previously like it was a different one. So you can create it. Yes, yes. From here, you can choose a new organization. If you want to create a new organization, you have to click on this top button, and you won't be seeing this thing in the first time because there won't be any organizations which are associated with your account. Click on You have to click on new, and you can create an organization and give a industry tag, whatever type of industry your like organization based out of. I'm back to Unity Hub, and after choosing the organization, you have to click on create project. It will start the Unity engine, and it will download all the packages and all the dependencies which are required for the project. So when Unity is launching, it will look like this thing. In the starting, it will take some time to open the project, because like it will be like installing all the packages which are required by the project. So you can see that it's installing the packages. So for now, like because of time constraint, I will show in the open project. Like when you open Unity, it will the window will look something like this. But maybe for you it will be looking different. If I go to this create, if I want to create a new scene, I have to right click here in the project window. In the assets, I have to right click, and then after clicking on create, we have to go to scene option. We can give it a name like test scene. So you can organize all these scenes and all the scripts and all the templates and 3D models and all those things using this project tab. Like if I want to organize this scene into a different folder, I can go and click on create, click on folder, gives it some name, test. I will just drag this scene into this folder, so it will move here. So when you open Unity for the first time, it will look something like this. I will give an overview of all the options which are available in this editor. So anyway, a new project has opened. I will show that as well. So this project window has all the content of your project, like all the 3D models, audio files, C# scripts, and all other DLLs and all those things. Like if you are like developing it on Windows, there will be DLLs. If you are like developing it on some other platform like Android and iOS or something, so you will be like having plugins also for that particular platform. So to see which platform you are currently on, you have to like go to file and then build settings, so you can see all the available platforms here. So currently I am on the Android platform. If you want to like go to some other platform like iOS or Windows, like currently, like because I'm currently on Windows, so we can't switch to iOS platform. We can switch to iOS platform, but we won't be able to build for iOS platform on Windows. We would have to like open this project on a Mac system. Then we can build the project using Xcode. On an Android or Windows system, you can use Visual Studio for scripting purpose. And this is the project window, and this is the console window. So whatever errors that will be generated in the project, they will be printing here only. It's similar to what a console looks like in a IDE. So this is the hierarchy. Hierarchy contains all the game objects which are in the scene. Game object is the like whatever you see in Unity, uh, it can be called as a game object. Game object means game object is a 3D equivalent of a variable. You can see main camera. So main camera is rendering whatever you are seeing in the 3D world in the game view. So it's a game object of type camera. So if I disable the camera component, you can see that Unity will generate a warning called no cameras are rendering, because there is no camera. So the three whatever is in the 3D world, it won't be uh, rendering on a screen. So that's why we need a camera, so that whatever we are seeing in the 3D world, we can render it onto a 2D screen. So scene view means like whatever you are developing, it will be visible in the scene view. And once you start the simulation of that particular scene, it will be appearing in the game view. Uh, let's develop a application, small application, in which you can get to know about all the various tools which are in Unity, available in Unity. So if I want to create a 3D object, first of all, let me add a plane to this 3D environment. Uh, I'm adding a plane by going to this hierarchy, right clicking here. You have to go to 3D object, then you have to choose plane. It will add a plane object in the 3D world. You can see that it's visible in the 3D world, in the scene view, but you can see that in the game view it's not visible because the camera is here, and it's not able to see the 3D plane which is in front of it, because the field of view of the camera is currently set to 1000. If I increase the far plane of the camera, so the camera has two component called near plane and far plane. Near plane means what the camera will be seeing, which is exactly in front of it, and the far plane will be the farthest, you can see that this will be the near plane and this will be the far plane, because increase to 10,000, but still it will not be visible because the plane is currently set at 000. Like the position of this game object is at this position x, y, and z, and main camera is at one height one. So I have to move it a little bit towards the camera and increase its height, and then I have to increase the height of camera also. If you want to set it automatically, you can go to scene view and go align yourself to the 3D view that you want the camera to render, and then click on this main camera, go to game object, and then click on align with view. So it will, what it will do is that it will automatically move the camera to the location in to the position and the direction in which you are looking in the 3D world. So you can see that the plane is now visible. So every game object will be having a transform component. Transform component is a vector 3. So it will be having a position vector, rotation vector, and scale vector. So what we are like used to, uh, the vectors that we are using in maths now, it's almost same in Unity also. uh, like xi cap plus yj cap is zk cap. So it's like telling how much units on x-axis the position has to be set on x-axis, on y-axis, and z-axis. And rotation are also, like, rotation is not a vector 3, it's a quaternion. So quaternion is a type of is an extension of xyz rotation values in the 3D space. Quaternion will be having four variables x, y, z, and one more component called w. But we are not used to four components in maths. So quaternions are complex. So that's why, like, to manage all these things, there is one more component called one more API called quaternion.euler. So we are used to Euler angles in maths. So if you want to do something in 3D world, it has to be in the form of quaternion. I will show about that later on. The plane has been added. If I want to like add one more game object, I will add a cube. We will do, what we will do is that we want to make the cube jumping, and we will be able to like move the cube around this 3D plane. So I'm like moving it a little bit. So you can see that it's a 3D object. So it's having uh, something called box collider. So box collider is a component which is used during collision detections. So Unity uses a physics engine to check for collisions in the 3D world, similar to what a collision looks like in the real world. Same thing, Unity also simulates in the real world using a physics engine. If I add a gravity like rigid body to this sphere, so what it makes is this rigid body component makes is that it makes this cube behave as a rigid body. Rigid body means like it will be interacting with the physics in the real world. Like if I move the camera a little bit farther, here I think it will be better here, or else here. So you can see that the cube is like into the air. So when some object is in the air, it will automatically fall down due to gravity. So this object will also fall down due to gravity if I enable this use gravity component. So what it will do is that it will simulate the gravitational effect in the 3D world for this game object. So we can give the mass and all various all the other parameters like drag, angular velocity, and we can also control the center of mass also. So if I click on this play simulation, because it's having a rigid body and use gravity component is turned on, so it will automatically fall down when I start this simulation. Like if you can see that the cube is in the air, but if I start when I start the simulation, it will automatically fall down onto the plane. You can see the cube has fallen. If I move it once again a little bit higher, it will automatically fall down. Uh, because of the gravity component. If I turn off the gravity component and move it higher, a little bit higher, you can see that it will no longer be falling down because the gravity is turned off. But as soon as I turn off the gravity, it will once again fall down because of the mass. So what I want to do is that I want to move this cube in the 3D space. So because these colors are looking too odd, so I will be assigning some color to this cube and the plane. I will create a folder called materials, and I will give a ground material to the plane. To create a material, we have to click in this assets window and right click here, create, then material. You can give it some name. To choose the color of this material, we have to like go to click on this material. Then in this like inspector window like shows all the properties of the material. If you want to change the color, you have to go to base map. You have to click on this icon. When you click on icon, all the colors which can be given to this object is shown here. So I want to give a brown color to it. So I will go somewhat here. So it has you can see that it's now appearing brown. So if I want to give the plane a ground texture, ground material, either you can go to this plane and in mesh renderer is a component which is responsible for rendering that object in the 3D space. So it's having currently having a material as lit. Either we can like take this material and drop it onto the plane to apply the material, or else like we can go to the material section and we can assign the ground material in the material tab. Whatever we are like doing manually, we can do it from code also. So that like when running the simulation, we are like everything is happening automatically. So for doing something like that, we have to like manage everything from from using scripting. That also we can do. I will show that also.
Bhanu Teja, sorry to interrupt in between. We are
Mhm.
running short of time, so can you please conclude maybe in next 5 to 10 minutes?
Okay, okay. So I will be creating one script to move this cube in the 3D space. To create a script like you have to go to this assets window, then click on create, and you have to click on this C sharp script. You can give it a name like cube controller, and if you want to like control this cube from a script, you can assign a new create a new game object called cube manager, and you can assign this script onto this game object. And when you double click on this script, it will open in Visual Studio or whatever the IDE that you are using with Unity, like Visual Studio, Visual Studio Code, or you can use Rider also. It will take some time in the beginning because like it will be generating all the libraries and all those things when you create a script for the first time. So like I have created the script now. So you can see this script is visible. Whatever namespaces that you want to use with the script, you can like write here. Like if I want to use some component called video component, I can like use unity engine dot video. But I don't require this video component for moving the game object. So I will show. I will be taking a reference to this cube in the start of the script. Um, Private. And because it's a private variable, if I want to it to be visible in the inspector, I have to serialize it.
Vana? Hello.
Yes, yes.
Yeah, Dr. Sagar Rani here. Sorry to interrupt you. The thing is, our valedictory session is scheduled at 9 o'clock. It was scheduled at 9 o'clock, but we are running out of
Okay.
time, and there is a test for participant at 9:30. So, if we do not stop at this point of time, probably we will not be able to do that. So, I request if you can just finish in next 5 minutes, that will be great for us.
Okay, sure, sure.
Yeah.
I think IntelliSense is not working right now because the too many projects are open.
Yeah, I think we should stop over here. Um, the participants, those who are interested, probably will contact you for the further implementation. It's hard time
Okay.
to stop over here because we have to conduct a small valedictory within 10 minutes and they have to go for the test as it is pre-scheduled on 9:30. We can't change that timing. That's the only thing. That's why we request you to,
Okay, sure, sir. So
yeah.
you can see that because I haven't given the reference of the cube, it's not moving. If I give the reference of the cube here, and also I will so you can see that I have written a small functionality so that I can move the cube using WS. So if I click on W, it has moved too fast. So what I have to do is that I have to reduce the speed because like it's getting called in the update function. So update is called every frame. So it will be happening too fast because it's calling every frame. If I add a value of 1f to the cube every frame, it will be too fast. So I will just write 0101f. So you can see that I can move the cube on the x-axis. This is the this red arrow signifies the x-axis, the blue arrow signifies the z-axis, and the green arrow signifies the y-axis. So you can see that the cube is moving every frame forward and backward. Similarly, we can do on x and z-axis as well as for the rotation also. So like as Sagar sir has said that time is a constraint. So like who are interested, we can like connect later on and we can like get into the advanced concepts also.
Yes, sir. Thanks for considering our request.
Okay, Sagar sir. So shall I wind up the session?
Yeah, yeah. You can stop sharing.
Okay, just I have stopped.
Yeah. ठीक है. सीता ma'am.
Yeah. Thank you so much, Bhanu Teja, for a session full of demonstration and case studies. I hope participants definitely got many wonderful information through your session. Thank you so much for accepting our request and joining the session. Now, I request participants, if you have any question, you may ask to Mr. Bhanu Teja.
Hello?
Hello.
Hello. Can we do that any medical test, brain scanning and all in the space? That simulation you can real time you can do the uh, testing. Is it
Ye-
possible?
Yes,
In
yes.
the,
Like for the medical simulation also,
Mm.
it can be done real time. Like what can be done is that the 3D replica of the patient's body can be created. Like whatever the surgeon want to like see uh, in real time, the 3D model can be developed for that. Or else like if they want to like see overlay the 3D content on top of the patient, it can also be done using mixed reality.
No,
Just
I'm
that it has to be
talking
developed
about
in.
space. In space, we can do the that how does it differ from space? Scanning and here anything can be being done in the ISRO space decks or what?
Yes, yes, yes. Like previously, I have like shown one demonstration also, no, for the International Space Station Mission ISS app.
Yeah.
So similar to that only, we can develop for our own needs also. Like previously, I have shown you this video in which like SpaceX mission of ISRO is simulated.
Yeah.
So similar to that only we can develop, but it has to be developed in a real-time engine. Then only like you will be able to see the output of that particular working model in the real world.
Okay. Okay.
Somebody
Yeah.
is like writing, I guess. Okay, okay. I will share my email address also. Uh, Hello, Mr. KG Gopinath. Has I answered your query?
Yeah. Yes. Yes. Yeah.
If you have any other questions, I have written my email also. You can like ask your query here. I will like write all the things in detail on your email.
Okay. Yeah. Fine.
Thank you so much, Bhanuteja ji. Now, as we proceed toward the valedictory function and we reach to the end of this FDP, I request all the participants to please share your experience that you have taken from the last 6 days in different sessions with different speakers. So it will be great for us to hear from you. So now session is open for all the participants. Those who want to share their views, please share with us.
Hello. Hello. Am I audible?
Yes, sir, you are.
Good evening. Myself, I'm KG Gopinath from ONGC, General Manager. I was involved. I'm retired now. The, the course has been excellently done, and it is a lot of topics were covered. As far as why I have joined this course is that uh, I happen to be in the internal audit of my organization, so that I have to do a lot of security audit and a lot of systems automation. Now they are being compromised and all. That we we do teach for our who comes for implant training and so that I want to upgrade my knowledge, and I've been uh, uh, um, empowered now to do some more topics, and thanks for that, and it is very it is conducted, and lot of new areas were covered. We go into underground, but here it is space. Uh, uh, the, in this regard, that a lot of systems which we use is that already developed, and now they are being used. also. Uh, that this regarding security is concerned, this Stuxnet and all those things, virus which was used for stopping the nuclear weapons of Iran in 2009. And in this regard, we also that earlier security policy was not there. Every organization should have a security policy. Otherwise, it is very difficult to sort out the what is the issue, and it is to prove the that it is only after that threats have occurred, we forced that as we were as an internal auditor, we forced our organization to go for internal that security policy, and then only they executed. And after that, the issues were naturally taken care by conducting regular audits in that following that ISO standard and all. So it is one way of doing that security threats. We could consolidate internal and external also. So thanks for the all the coordinators, and thank you very much.
Thank you, sir. Dr. Arun Kose, sir.
Yes, actually, I am a ex auto factory person, and I know that how much conventional emissions we used to make these days and earlier days also. But this course really given an insight that lot of technological changes have been done, like in AI, ML, and crypto. Lot of things are there. We really got an insight that whatever the things going on in the warfare, how much lagging we are in, say, production and then using this technology. But we have to, just take this technology, and I think we have to develop all the things in indigenously. So thanks to give us an insight on all of on the development in the this new technologies in defense. Thanks a lot.
Thank you, sir. Any other participant want to share their views? So thank you so much all for joining this FDP and making it successful. Now I request coordinator of faculty development program, Dr. Sagar Rane, to please give vote of thanks.
Yeah, good evening all. Good evening, research faculty and dear participants. As we come to the close of this insightful and enriching AICDT Atal sponsored faculty development program on defense dynamics and space exploration, I am honored to present the vote of thanks on behalf of the organizing team. First and foremost, I extend my heartfelt gratitude to Brigadier Abhay Bhatt, Director AIT, for gracing this program as our esteemed chief guest. Uh, his invaluable presence and inspiring words, as well as a one session on information warfare, had truly added great significance to this event. So, thank you, sir, for your unwavering support and encouragement. We are immensely grateful to Colonel M.K. Prasad for his visionary leadership and guidance in hosting this program. I would like to also extend a special thanks to Dr. B.P. Patil for his outstanding support in providing invaluable assistance. I extend my sincere appreciation to Dr. Sunil Dhore, head of the department, whose contribution in making this program a success have been integral. I would like to express my deep appreciation to all the distinguished academia and industry speakers for delivering such a wonderful sessions in this faculty development program. Their expertise and insights into defense dynamics and space domain have significantly enriched the knowledge of our participants, and we are grateful for the time and effort uh, you took to share your experiences with us. Special thanks to all the participants for making this event more interactive and interesting. Thanks to my co-host, Dr. Sita ma'am, for helping me in smoothly coordinating and conducting all the 13 sessions. Last but not the least, thanks to AICT for giving the opportunity and funds to organize such a wonderful FDP. I would like to thank each and every one of you, our head of the department, deans, participants, faculty members, guests for your active participation and engagement throughout this program. It is your enthusiasm and eagerness to learn that have made this initiative truly impactful. On behalf of the entire organizing team, I wish you all the very best to apply this gain knowledge into your future endeavors and maybe continue to collaborate and grow in this rapidly advancing field of defense and space. Thank you. Thank you so much and happy learning.
Thank you so much, sir.
Thank you, sir.
Now, as we have only 5 minutes to start the test, so I request Sagar sir if any last minute information you want to share with the participants.
Yeah, sure. So the test has been scheduled onto the AICT Atal portal. Kindly note that this test you can give only once. There is no second chance to give the test. It will not start exactly at 9:30. That means if you are login on 9:35 or 9:40, it will timer will get counted from that period, and you will get complete 1 hour 60 minutes to give this test. There are 30 questions, each question having 1 mark, so there will be total 30 maximum marks for this. On your AICT Atal portal, inside your login on the left hand side panel, probably you will be see the assessment section, and into that you will see the application ID of this FDP, and on the right hand side you will be able to see the link, test link. Once you click on that and then accept all the terms and conditions, probably you can start the session. As a lot of people simultaneously will go for attempting this test, probably you will not be able to get access, and multiple times you will be able to log out into from this system, as multiple FDPs are scheduled on same day, same time, all the timings are same. So don't worry, once you log out, again try to log in, and the counter will start from that period only, so don't worry about it. But once you submit the test and the marks has been generated at our end, we can't do anything. There is no second chance to give the test. That's what I'm repeating again and again. And if you want time, you can take 10 to 15 minutes time to set up your laptop, your internet connection, and be there with full attention, so that you can try to attempt the most of the questions and get good marks. Yes, so that's it from my side. If you have any questions, you can ask. Don't be in hurry, because 2 to 3 weeks back we conducted one FDP, and again we took the test on the same platform. Lot of participant face lot of issues while attempting that. Don't try to attempt the test through mobile phones. Uh, can you mute yourself? Who is unmuted? Please check, because on it the website AICT Atal website is not mobile friendly. Whenever you will try to attempt through mobile phone, probably you will not be able to see all the buttons into that. So I request everyone, take your time. It is not the thing like it will get started on 9:30. Even if you are logging into 9:45, the counter will get started from 9:45. But don't delay. Probably I don't have exact timers. After 11 or 11:30, probably it will get closed. That's how we experience in the last FDP test. So that's it from my side. If you have any questions, any queries, please ask before attempting to do test. Yeah, anybody? Those who are not able to see the tests right now, don't worry. It will get generated in some amount of time. So please be there, as lot of people are trying to attempt simultaneously. You will not be able to see. So that's how it works. Okay? Any questions? Any queries that you have?
No, sir. Thank you. Thank you for
Okay.
support.
Okay, chalo. All the very best to all of you. Just do it. Thank you.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, ma'am.
Thank you, ma'am. All the best to all the participants.
Thank you, sir.
I declare end of the FDP here. Thank you so much, all of you, for joining. All the best for the test.
And if you have any questions, any queries, you can put that into the WhatsApp group. Now we are closing this meeting. Thank you.